My name is Marissa. Today I'm going to show you some of the features in 2022 R1 release of Ansys Mechanical. Let's get started with importing geometry into Mechanical. In the example you see here, we're executing a script to highlight the new capabilities. All geometry import and assembly actions within Mechanical now use the new object, Geometry Imports. Not only does this do away with operations in Workbench, but this new workflow also enables several enhancements that were previously not available or required you to incorporate in other features. You can now quickly change, update, assemble, or remove parts, incorporate part transformations to specify translations and rotations, reduce the need to interact with upstream geometry applications, define individual import preferences, and employ APIs for script and add-in development. New Substructure Generation Analysis. A new analysis called Substructure Generation is now available in the application. This analysis enables you to perform a generation pass that creates one super element from a group of finite elements. This super element that represents ROMs, that is, reduced order models, not only lets you save simulation time when compared against the whole model, but also encourages you to share models across engineering groups without the need to share an entire finite element representation. Simulation of a directed energy deposition process. Additive manufacturing capabilities have been expanded to include the detailed simulation of a directed energy deposition process. With an easy-to-use DED wizard and new simulation techniques, manufacturers using DED processes can now use Ansys additive solutions to prevent failures, excessively deform parts, and reduce the time and cost to qualify parts and machines. In Ansys Mechanical, you can define the 3D printing tool path directly using a G-code machine file or manually using name selections. The simulation uses a birth and death technique of element clusters to follow the tool path and simulation of the welding process. You can easily visualize the tool path and the progression of element clusters before solving. Typical results for the thermal structural system include temperature and deformation contours. Probe Label Node ID Display. There are a few new general graphical display features that are now available. The probe and the annotation label features have new display options that enhance the capabilities of the features. When the Results Context tab Snap option is active, probe labels display the ID of the node for where you place the probe. This enables you to make future references to a specific result value for a particular node. A new column in the Graphics Annotations window also displays the node ID. The Graphics Annotations window also has a new column that enables you to change the color of a label. This is a general visual improvement you can use to distinguish between specific probes values or between desired labels. And the new Show Always column enables you to display user-defined annotation labels continuously when you select the checkbox. The associated labels remain displayed regardless of the object you select. This tool is a visual enhancement that lets you provide context for an area of interest on your model. LS-DYNA new features in Workbench. The LS-DYNA Workbench system now supports materials for foam and impact applications, including crushable foam and fabric. The new imported displacement object allows you to initialize the mesh towards a final mesh, moving nodes at different rates to allow an expansion of an object to provide pre-stress in the model. During the analysis of the model, displacement can be modified in a small restart, allowing you to analyze a sequence of events using the results of one system as the initial position of the next. Be sure to download our latest release from the Ansys customer portal and check out ansys.com for more release content. Thanks for watching.